Hello, this is Mrs. Taylor, and I'm going to walk you through how to apply what we've learned with radicals to using the distance formula. So on the work you were given in class, you were asked to find missing variables for each problem, and what that meant is that you had a pair of coordinates and you had a distance given, except one of the values of the coordinate pairs was missing. So in other words, it wanted you to solve for the variable. And so what we learned in class is the distance formula, which is based on the Pythagorean theorem, is d equals the square root of x squared minus x1 all squared plus y2 minus y1 all squared. And x2, x1, that means the first x and the second x, y2 minus y1, second y and the first y. And what we learned in class is that it doesn't matter which order pair you label as your x1, y1, x2, y2, because you're subtracting and squaring, so your result will be the same either way. But I'm going to go in order, so I'm going to label my first order pair x1, y1, the second order pair x2, y2, and then of course the distance is 5 square root of 2. And so where we'd start with this is we would take what we have and plug it into the distance formula. And so my distance is 5 square root of 2, so that's what I put first. And then I have equals the square root, and then x2 minus x1, which would be negative 1 minus negative 2. And then y2 minus y1, well, y2 is what we're solving for. So I'll write that as y, because that's the variable that's there, minus negative 2, all squared. And so from there, what we would do is simplify first, because simplifying makes it easier to solve. And what I can simplify is what I have here inside the parentheses, negative 1 minus negative 2. Minus a negative becomes plus, so negative 1 plus 2 is 1, and then after you do that, then you square it. 1 squared is 1, so all of that in the parentheses is simplified to 1. And then just because it's easier to work with, instead of writing minus negative 2, I'm going to write plus 2, and all that is squared as well. Now, what we've learned is that if I have a radical and I want to solve for a variable inside the radical, the way that I get rid of it is by doing the inverse operation. And in this case, it's the square root. And what we learned with radicals is the inverse is to raise each side of the equation to a power equal to the index. And so square root has an index of 2. There's no number written there, but we understand it to be 2. And so what that tells me when I'm solving is to raise both sides to the power of 2. And what that will do is eliminate the square root on the right hand side. And so your result would just be the radicand, which is y plus, 1 plus y plus 2 all squared. Now, on the left side, let's review our exponent rules. When you have a product that's being raised to a power, remember each item gets raised to that power. So 5 squared will be 25. And then just like on the right-hand side, when I raise the square root to a power of 2, the power of 2 eliminates the square root, and you're just left with the radicand. You can also work it out where square root of 2 times square root of 2 is square root of 4. The square root of 4 is 2, so it simplifies to 2. Alright, and then 25 times 2 is 50. I'm going to write over here where I have more room. Alright, so now what we have left is 50 equals 1 plus y plus 2 all squared. And remember, anytime you're working with equations, you always want to add and subtract first. And so what I have is 1 plus all of this. And so what I can do is subtract that from both sides. So what I have now is I have 49 equals y plus 2 all squared. And just like before, where if we're trying to get rid of the square root, we square it. The reverse is true. So if I'm squaring something and I want to get rid of that exponent of 2, I would take the square root. And remember, whatever you do to one side, you do to the other. So take the square root of both sides. That would be 7 equals y plus 2. And then subtract 2 from both sides, just like you would in any equation, and y would equal 5. So that's how you would solve for that missing variable. And that's how you use the distance formula with radicals.